Hi there, and welcome to today's webinar titled Improving Industrial Maintenance with the Internet of Things, sponsored by Infor. I am Mike Hockett. I'm the editor of Industrial Maintenance and Plant Operation magazine, also known as IMPO for short, and I'm also the editor of Industrial Distribution magazine. Both ID and IMPO are two of Advantage Business Media's manufacturing brands, and I'll be moderating today's discussion. Predictive maintenance is a big topic among our IMPO readership, especially as it concerns all industrial manufacturers. Other than employee safety, factory, warehouse, or other facility downtime is the top concern, arguably, among facility operators in this space. It has been that way seemingly forever. Meanwhile, we keep hearing more and more talk about the Internet of Things in manufacturing. More specifically, the industrial Internet of Things has become the buzz phrase in manufacturing in recent years, and it figures to have major implications for industrial maintenance. More and more manufacturers are discovering the maintenance benefits they can achieve by optimizing their facility's maintenance schedule based on condition monitoring. This involves the task of data collection and making sense of that data. Many manufacturers have been collecting operational and performance data from their equipment for some time now, but only some of them know how to turn that data and feedback into actionable insight that will improve their overall efficiency and bottom line. Today's webinar will cover a number of subtopics aimed to educate our audience on the industrial maintenance areas that are showing the greatest gains from leveraging insights about the data collected from maintenance management and condition monitoring, as well as the tools you will need to make it happen. And to dive into these two areas, we've recruited a couple industry experts to share their knowledge and analysis. Kevin Price has more than 20 years of experience in the Enterprise Asset Management, or EAM, solution area for Infor. He served in multiple leadership roles in sales, service, development, and product management. He is currently the technical product evangelist and strategist for the Infor EAM portfolio, which includes EAM, MP2, and Spear technologies. Kevin is based out of the Infor EAM Development Hub in Greenville, South Carolina. Tin Nguyen is a director of product marketing at Burst, where he is responsible for product launch and go-to-market activities, including targeting, messaging and positioning, content creation, and sales enablement. So thank you to Kevin and Tin for being here today. For any audience member viewing this live presentation, you can send us your questions on this topic in the content via the chat box, which we'll use during the Q&A session following our panelist presentation. Also, this webinar will be made available on demand starting tomorrow, so starting then, you'll be able to watch it anytime and share it with anyone. So without further ado, I'll turn things over to our first presenter, Kevin Price of Infor.
Wonderful. Thank you very much. And I'm glad that you took the chance today to be able to spend some time with us. This topic that we have today is near and dear to our hearts, of course, and I'm sure near and dear to yours. But try to understand exactly what it is, how it works, how it moves, how you understand it, how you get value out of it. These are questions that are really hard to answer. But when you start to peel back, what you'll find today is going to be interesting. It's not as hard as you think. When you think about the Infor Internet of Things, the approach that we're taking, it's really basic in its essentials. There's things that we do in the application to be able to store. We've always done that with the asset management perspective, right? We've always had an asset management system out there since the asset tracking days to really track the condition of the asset. And then, of course, over time, the different activities that affect that condition, things like work management activities, project management activities, refurbishment activities, contractor activities, you name it. But we had to capture that, and we did it in different ways. And we developed that over the years. With the Infor Internet of Things, we're going to be able to do a heck of a lot more now. And it's why we can understand structure better. If you look at what you have in this particular slide, really taking a look at going from bottom to top, you can understand how this could work. In the beginning set, what you have to do is really understand how to acquire information about that asset. Acquiring that information about asset can involve a lot of different things, and we're going to talk about that in a moment. But understanding how to acquire information is essential to understand the condition. Are there meters that you have to have? Are there process logic control systems? Are there SCADA systems? Are there different messaging systems? Is it an integration that you have to pull out? What is it that you have to be able to put your pulse your finger on the pulse of that piece of equipment. Now from there, what do? You have to take it. You have to push it somewhere, right? You have to start consolidating that information. Now we've been doing this for years with the Infor EAM application. But with the Internet of Things, this data is so much larger, so much more complex. You're looking at, instead of like a little pond of data, an ocean of it, a lake of it. You'll hear that term a lot come out about data lake, big, large sets of repositories of data, so you have to push it. We do this very well within the Infor family because we use the Intelligent Open Network. This is an opportunity for us to be able to send well-formed business object documents to a repository for proper analysis. From there, it has to be processed. It should be well-formed. It should be shaped. It should be applied against other areas. From there, we process that information against those rules, and then we do something about it. We consume it. We push it out. We have decision as a service, if you will. What if you could have a monitor on the pulse of your piece of equipment, and then over time, that data that's captured could trend against prior solution codes, prior failure codes, prior problem codes that you've always had, and give you options to repair on demand. These are things that we can experience. These are things that you can experience by implementing some of the opportunities that we have with the Internet of Things. Taking a look at what's out there. Take a look at what people are saying about the Internet of Things and what type of priority they have on it. Well, everyone has it as a priority because everybody knows that data is everywhere. It's so pervasive. Information about where you are. Right now, I can track where my kids are with Find My Friends app, and I'm sure they enjoy that. But the point is I can know where they are. Location-specific data, condition-specific data, problematic data. There's so many different things that I can do to be able to track that and bring it in. Our customers see the same thing. They understand that it's a problem. They understand that it's a top 3 area problem of opportunity, but at the same time, what do you do with it? Where does it impact? What do you think? Well, some people believe there's an impact that's out there that's pretty major. Some minimal, some moderate, and some really don't know. And unfortunately, that's what we see as well. It's across the board. And why? Because nobody really fully understands, not nobody, but the majority of folks don't really fully understand how to sink their teeth into it. Why should you sink your teeth into it? When? To what extent? For what reason? There's so many different reasons out there. Proactive maintenance management strategies, predictive maintenance management strategies. What about capital planning, forecasting, 4, 5, 7 years, when to replace what? All these types of visualizations that are out there at your hands you could take advantage of. These are things that have huge benefit. If you look at this particular flow and what it has from left to right, what you'll find are the different areas of opportunity that EAM benefits, right? These are things that you'll find within productivity, doing more with your workforce. Why is that? Well, mobile is an example. Going to a digital transformation and using those devices that they have allows you to do work and record it at the same time. Technicians don't need to come back to an office. One of our partners say all the time, jokingly, but it's true, is one of the most unnatural acts you could ever see in the industrial manufacturing or any engineering environment is a work order technician in front of a computer. And why is that? Because they're introducing you to a session. They're interacting. They're forced to put in data, put them out in the field. Put them out in the field, do what they love, do what they enjoy, do what drives them, but just give them a tool to accentuate that. So productivity elements like that are common. What about other things, equipment utilizations? What about other stuff? Just on and on and on. There are so many different things that are built into opportunities to improve upon EAM, and we've always seen these. We've always seen how it works. We've always seen where it come into, but there's new opportunity that we can look into. We can actually affect bottom line. We always have, with productivity gains, with uptime improvements, with shrinkage controls, with an inventory, with all these types of things. But we can really impact the bottom line for so many people. Revenue models, we can get equipment out. We can have it running when it's supposed to. We do things faster, better, cheaper. We can also have better effect on return on assets within a balance sheet in a bigger way. So the opportunity that we have to look at what you can do with the Internet of Things, especially around classic asset management strategies, is not just compounded but excelled within what you'll find in the Internet of Things. Urgency is another component. What would be the top concerns if your business were not to implement an IoT strategy in the next 3 years? Competitors will gain a cost advantage. New and innovative services will come out that we miss. May become harder to stay compliant with our regulations. All that's true. That's why you're on the phone. I'm sure you're on the phone to understand how you can improve. Everyone is there. But there's also, what happens if I don't? What happens to me? Am I going to be in the headline? am I going to have to report to my superior, what's going on and what we're missing and opportunities that we could have capitalized on? Maybe, I don't know, but these are things that are on top of everyone's head, really upfront and obvious. What about how ready is your organization to capitalize on the Internet of Things? You hear from your vendors all the time, the original equipment manufacturers, hey, we have all these different types of meters to give you all this data. Why do you have an asset management system anyway? We can tell you when work needs to be done. Predictive, we do that all the time. We can tell you, no problem, just connect this device, do this thing, and we can tell you when it's going to fail. There's a lot that's going on there. There's a lot of moving parts, a lot of plates on sticks. But are you really ready? How do you answer that? It's very difficult to answer that for many reasons. We're going to talk about in a second. But one of the things that we always find the most difficult is to be able to understand what the elements are to doing it. And even taking a step before that is which particular assets do you focus on. You have to focus on the things that matter. The person that succeeds the most does the fewest things but does them very well. Always learned that from my history. Always learned that from other people that I look up to, my mentors. When you really distill it, though, find out which equipment matters to you. Be going through a risk analysis, and we're going to talk about this at the end. But after you figure that out, it's pretty basic. Get the right people involved at the right time. How do you identify that person? Well, they need to have reliability backgrounds, probably. They need to have other people involved, electrical engineer, mechanical engineer, computer science engineer, perhaps a data analyst, perhaps a system administrator. I don't know. There are a lot of different things that are different disciplines that will be involved to be able to go after a problem. Devices. How are you going to talk to that piece of equipment? How are you going to get data out of it? How are you going to rationally communicate the elements that you need to be able to run a report on? Okay, once that's done, you got data, a lot of it. Now what do you do with it? How do you make sense of it? How do you churn it? How do you make it automated? These are basic questions that are out there, but these are basic questions that can be easily answered. You just kind of have to understand what the use case is going to be for you. So take a step back. If you're sitting at your desk, put your feet up. Grab your coffee, grab your sandwich, listen for a second. What are the things that qualify as a complete use case? Well, usually it's ones that you can really identify easy. It's ones that you can be able to get data for. It's ones that affect what you do in a big way, and it's ones that you can write reporting to. Think about that. That's pretty much everything, and that's the problem. If you look at where you impact and the different areas across the enterprise that can impact, it's everywhere. How you deliver service, the service level agreements that you have for that particular piece of equipment, if you're doing field service, the service level agreements that you have committed to your production engineering environment, the service level agreements that you have committed to your operators. There's so many different issues that are there. How quickly you're able to get product out the door, how quickly you're able to make equipment safe, fluid, structured, reliable, all these things. It enables everything we touch. So the question is, again, where are the benefit areas? Well, if you look at some of these are different areas of opportunity. A couple of them we've highlighted just to give you a flavor for it, but if you look at some of these, like the assets area, right? Optimize schedules. Monitor different types of locations that you have different things. If you have pieces of assets that are out there in the field that are critical to what you do, and the time to get them up and running again is important, make sure the tool's there. Make sure the people are there. Make sure your education there. Make sure your materials are out there. And that's the things that you do all the time. How do you monitor that? How do you automate that? How do you find condition about that in as real time as you can? Think about it. Impact that you can make to a particular operation is to keep that asset running whenever it should. If it runs down, if it goes out, if it dies, what do you do? These are areas of opportunity, areas of impact. It's not that difficult. If you look at the return on assets thing, this is the thing the CFO always wants. Spent billions of dollars on these assets. I want to make sure I get my bang for my buck. Have I? Will I? Won't I? Think about what we call the SAIL technique. Sense, analyze, intervene, learn. SAIL. Try to keep it simple. If you look in here, what do you do to be able to understand that return on assets? Sense it. First, understand its temperature, perhaps, vibration, wear, consumption, visualization. Analyze. What's the maintenance history that's involved in that? When did it go out? What's the useful life supposed to be? Then, once you understand these two components and they're brought in, intervene. Let our operators know. Send them an email. Send them a notification. Send them something. Let them know they're about to hit a threshold that can actually damage a piece of equipment, or it could have a predictive maintenance issue come up on time, and then learn from that. build into the process of automation, build into the process of remediation, build into the process of risk mitigation an opportunity to be able to learn from that example. Production efficiency qualities, these are some of the same things. Sale technique, sense, analyze, intervene, learn. Understand what your throughput is. Understand what schedules you have. Materials are on hand. Some places in the world you can't really impact lead time because they're in areas like Lord help the people in the Caribbean right now because there's so many materials out there. They're all competing for the same thing. Typically you can get something in a week or two, but now it's taking 6, 7, 9 months to get something that's out there. You have lead times that change based on equipment, based on vendor. There's all these different types of things that you can build into it, but if you start to sense and analyze this information as it goes through, you can understand when to order, how to order, and to what extent. There's a lot of different opportunities. Operational efficiency, sale, sense, analyze, intervene, learn. Understand what that particular vehicle is doing, where it's doing, what its levels are. What resource schedules you need to have in play. If you have a vehicle that's out there in fleet management, for example, take the telematics off of that. Put it in the system. Be able to communicate where that vehicle should go to be able to have work done on it because you have the people, you have the place, you have the tools, you have the equipment, you have everything that you need at this particular location. All you have to do is communicate that back out. These are a concert of information, a symphony of data that's brought about. Product performance, making sure it's operating correctly. All these, you can just go on, but the problem that we have, as we mentioned before, is there are disciplines that are involved. This isn't just a one-size-fits-all as we've always been used to. This particular approach involves a lot of people. Reliability engineer, as an example. That's common, right? Why? What makes this asset reliable? What doesn't it? I mean, this reliability concept has been around for a long time, but we're starting to see more of it, and that's good. Asset performance management is a new model. Not really new. It's been around for a while, but it's starting to impact everything we do, and this is a good thing. This is not a bad thing. Computer science. Why is that in there? Because we have to communicate this data. You have data analysts, business analysts. You have integration specialists. You have different types of ways to be able to obtain that information. SCADA systems, process logic control systems, you name it. Industrial engineering. Why is that there? Industrial engineering really affects so many different things. The problem is how do you get these three, if not more, engineering disciplines into one? How can you be able to take a reliability engineer and synchronize it? Computer science engineer and industrial engineering and synchronize it. It's a difficult process to do, but it can be done. Once you can be able to get there and understand exactly how it's structured, this is when you really realize value, significant value. Now, in the beginning, as you start to structure it and roll it out, impacts may not be as wide. Impacts may be not as deep, but they're going to be there. And the question is what do you do with it, how do you do with it, how do you take that technique and formulate it, how do you roll it out in other areas of the organization. This is what we've done in some examples like the City of Des Moines. City of Des Moines did an opportunity to be able to implement based on energy utilization. Bill Miller, who was with this organization at the time, implemented an energy efficiency and conservation block grant monies that came from the federal government and implemented it in a way to understand how to be able to spend less on energy. That was the main focus because that was the main dollar amount. If you think of all the equipment that you have that use water, air, gas, electric, steam, something, that expense is huge. What can you do to impact that? That's big. So to do that, he had to do the sales technique. He had to figure out a way to understand the data, to get it, acquire it. He understand how to analyze it, how to intervene with it, how to learn from it, to be able to understand how to be able to maintain it, to be able to understand how to operate it, to be able to understand how to run it at different times perhaps. And the impact that he has been so significant. Energy footprint reductions in big ways. Dollar amount utilizations in big ways. Understanding equipment efficiencies, longevities, recommission activities in big ways. This is a wonderful thing. This is where an organization that has obtained an ISO 55000 certification and more, really good to look at. Or what about another area of the business outside the public sector? This is in manufacturing. You can see here, this is an example to understand the critical fleets that they have. This is Grimway Farms. One of our user advisory board members drives this. We actually had some presentations that she did, Katie Diesel, did at Inform last. It was a wonderful thing. But the idea that they have is they're trying to understand what's going on with these vehicles. Farming is big for them. They need to keep these pieces of equipment running, know where they are, know what condition that they're in, get as much data as they can about this to make sure that they're running at the right place at the right time, for the right type of harvest or set up or different types of things, and be able to push it out in a big way. Understanding where it is was interesting. GPS, it's there. It's everywhere. You can understand how to utilize that, how to push it through, how to bring it about. It's a wonderful activity, but even more than that, what we're going to show now is a quick view over to a new technique. Not necessarily completely new, but starting to come out new in legislation, allowing us to be able to obtain condition data through drones. Let's take a look at the video.
We like to think of ourselves as an information system in the sky. What basically EAM and DINGS does, it brings all that together into one screen so you can make your assessment quickly.
When you get a drone, you think you're going to use it for maybe one or two or different 3 applications, but you end up finding new applications to use it for daily. We have thousands of assets that are keyed into the enterprise asset management system. From a safety chair perspective, you know, I think about all the injuries, and a lot of those are people falling off ladders. If we could even reduce that just 50%, that would be saving us millions of dollars.
So the thing that you're probably looking to hear is coolest thing ever. That's probably what you're thinking. It's okay. It is. This type of stuff that we can see and that we can experience in our worlds that we have in ourselves of our own little gadgets are things that we can incorporate into our daily operations. These are things, drones, that can give us views of various capacities, things that involve not only just overview video capture, but it can also collect payloads in terms of data elements, payloads in terms of different types of heat signatures, different types of elements that are out there that are phenomenal operating opportunities for us to understand the condition of an asset. So where do you start? Very quickly, understand where your risk is. Find out what assets are important, what are not. Conduct a value on those high-risk elements. Go through and understand what the condition approach is going to be, and you have to need to detail out why you're going to access it, how you're going to access, what are you going to do with it, and once you can do that, execute it. Throw it out there. Let it run. Find out what the data is. Now you got to figure out what the data should say and why it says that. Analyze it. Visualize it. Then from there, understand what you can do to change, whether it's an operation structure, whether it's a preventive maintenance structure, whether it's different tooling, different parts, different vendors. I don't know, but figure out how to improve that number that you gather, and then repeat, rinse and repeat. But to do that, you have to have a strong engineering capacity in so many ways, and one of the biggest ones that we can offer, that we can go into, is a new acquisition for us. It was an acquisition of a company called Burst. Burst is an opportunity for us to be able to visualize the data sets that we have to take an understanding of condition to a new level. And with that, I'm going to pass it over to Tim. Thank you for your time. We'll talk soon.
Thank you, Kevin. Hi, everyone, and thank you for being here today. So I will be talking a little bit about how analytics plays into industrial maintenance and really why there's a need for it. So just really to start off, a quick primer on Burst. Like Kevin said, we were recently acquired by Infor back in June, so now we're happy to be a part of the Infor family. Burst is an end-to-end BI platform. We have a complete analytics stack from ETL, data aggregation, to data prep, analysis, visual reporting, dashboards, and mobile on the front end. We were born in the cloud, meaning we're a multi-tenant cloud architecture, but we work with all deployments models. So whether you want to put your data in the public or private cloud, on-prem, or do a hybrid model of the three, we could do that for you. We're highly ranked by leading industry analysts, Forrester, Research, and Gartner, for our BI solution. And we've just been awarded 2 broad patents for what we call SMART, or AI and machine learning assisted data prep, data discovery, and visualization. We were built for the enterprise, so we're not just some analytical desktop tool that you download and plug a couple Excel files in and start playing around. And lastly, we're founded by industry veterans with 400 plus years of company analytics experience spread throughout Burst. We have customers across all industries, all sizes, and spanning numerous use cases. I've highlighted a handful here, Reckitt Benckiser to Tata Motors. All these are really market leaders that are doing advanced analytics and driving complex use cases that deliver significant value using Burst. But now, really jumping into the purpose of this webinar, I'll be talking about industrial maintenance and IoT and how analytics really plays a part of it all. Maintenance managers, engineers, operations personnel, everyone's responsible for ensuring hundreds of assets and machines are up and running efficiently. I think like Mike has started the webinar off, one of the most critical things is maintaining uptime and making sure the machines don't go down for very long. Plant and equipment downtime is costly and causes delays in the production schedule, and this really cascades into delayed orders, late deliveries, and then customer satisfaction goes down and hence revenue. Throughout the years, maintenance operations has evolved and is continuing to evolve as new technologies and solutions come out. You initially started off with reactive maintenance, right? When things broke down, you would go out and fix it. That was pretty simple. Then preventative maintenance came where you would do maintenance based on a fixed schedule. There's certain time or usage thresholds that dictate when maintenance would occur. Equipment is routinely checked by technicians who hopefully would catch an impending breakdown. Yet this strategy and research is showing that this is still used by a majority of manufacturers today. This is terribly inefficient, right? We all know that. Labor costs are unnecessarily inflated. Machines end up having no issues whatsoever, but are still manually checked by people. And yet, furthermore, there's no telling what will occur between schedule and inspections. A machine or asset that's showing no signs of breakdown during a routine maintenance could begin to break down the very next day without anyone really knowing. And then it could be weeks before a technician returns to conduct another inspection. Then came what we'll call manual predictive maintenance. Companies started to listen to the condition of their equipment, right? Taking measurements and monitors with sensor devices. This has been around for quite some time, but it often requires an operator to physically go out and measure the device. They would go out on a schedule, take readings, capture all that reading, and plot it out, typically in Excel. They would spend hours creating spreadsheets. Then, based on all their analysis, they would come up with a predictive maintenance schedule based on the condition of the equipment, right? This was a great idea and thought, but execution was done on an ad hoc basis due to the manual nature of everything and the long lead time to really building out a predictive model. Now, with the advent of IoT devices, you can now take advantage of having real-time sensors installed on equipment. IoT-driven sensors can be attached to factory equipment to record and compile millions of data points around the clock. They provide real-time data on equipment, monitoring for pending failures. Sensors embedded in equipment check for abnormal conditions and can trigger work orders when safe operating limits are breached. Most equipment manufactured today have built-in sensors, and for older equipment, there are simple ways to retrofit assets with sensors. Companies can now put the data into predictive models to help determine when something is about to fail or what the remaining useful life is for that equipment. This allows managers to know which equipment needs maintenance, maintenance work can be better planned, systems remain online, and tasks are performed only when they are needed. So, why then the need for an analytics solution? Why can't you just go out, buy a bunch of sensors, start collecting the data in a control system and go? Well, the current reporting on an EAM, ERP, SCADA, maybe plant historian, these are more or less one-dimensional. Many maintenance managers and operations personnel actually just download the data to Excel to do basic analysis. And the larger the data set, the slower the Excel runs and the longer the reporting takes. And this is only exacerbated with IoT data, as now you're working with millions and millions of data points, within an hour or maybe even a day. Additionally, these reports fall way short of providing stakeholders with any real insight that draws any attention into plant efficiency, asset effectiveness, any bottlenecks in the production, and any unmitigated risk in their maintenance operations. And if you think you can't do any of that, how are you supposed to build a predictive maintenance model with all this data if you can't even get, the first couple things right? Furthermore, all this data is siloed in a system that is held, right? It could be held in an EAM, it could be held in a data lake, it could be held in a Hadoop system, in a SCADA. To get a correlation between all this data coming from different data sources takes some serious work. And let's not forget, the data that you're dealing with is ever growing. So the slow performance you're experiencing now will only get slower and slower until your analysis grinds to a halt. The dirty little secret about analytics, though, is that the back-end management of data is actually really hard. Your team, or maybe your company, has a data science team or even just an analytics team, and they're spending their time extracting data, cleaning it up, transforming it into an analytically ready kind of table or set. They're probably even combining a few data sources together to get a more complete picture, or what they think is a more complete picture. And then, think about this. After all this, then they can finally do the analysis to hopefully find an insight. This takes weeks and or months, and you don't have time to do all that. A good analytics solution, then, is needed. An analytics solution offers companies the ability to extract, transform, and aggregate existing data sources into one centralized data model, and to run analysis to identify patterns in asset performance to make better business decisions. If you want to run more advanced analytics like data science algorithms, you could take all this data within your analytics solution and push it to a data science platform such as R or Weka. An analytics solution is also a cost-effective way to aggregate, store, and use advanced analytics against massive amounts of data coming from equipment and combine this with other data sources. Also, today analytics solutions are becoming even simpler to use, even for people without any advanced statistical knowledge. And the analysis isn't one of these one-off analyses that are done in Excel. Once you build your reports, your models, your dashboards, you could have the data refresh and loaded to your liking. It could be hours, it could be days, it could be weeks, really up to you. And everything automatically updates for you. There's really no waiting around. But more importantly, analytics drives value. According to a recent survey conducted by the Aberdeen Group, best-in-class companies are increasingly utilizing IoT and big data to implement predictive maintenance models to address and improve their operational goals. Some of the report findings show that companies reduced unplanned downtime to 3.5%, improved OEE to 89%, reduced maintenance costs by 13% year on year, and increased return on assets by 24%. And these are just the quantified value. With analytics and predictive maintenance, companies can do so much more. You can increase equipment lifetime, improve plant safety, prevent costly waste and rework, reduce energy consumption, and reap the benefits of a stable asset performance and increase their ability to achieve high production attainment rates and produce high-quality products. But that's not all. Organizations are also using the underlying information to enhance customer engagement, differentiate their business, and create a new revenue stream all out of the data. And I'll get into that a little bit later within my presentation. So everything sounds great. We need data, we need an analytics solution, and boom, we're off and running, right? So how do you really get to a predictive maintenance model? Predictive maintenance requires A, data to be collected from the equipment sensors on a frequent basis. B, the data needs to be analyzed for possible patterns of failure and normal behavior patterns to establish a, safety threshold. Sounds simple enough, right? But the mistake many companies fall into is that they obsess over data analytics without really any strategy. They assume that all they need to do is to gather as much data as possible, and then this data will magically become knowledge, and knowledge will magically become wisdom. Additionally, we need to remember that IoT sensors generate a significant ton of data, something I've mentioned often before. And without the right strategy in place to collect and leverage that data, manufacturers can end up drowning in the data that they don't use or miss opportunities to improve business efficiencies. So we have a simple 6-step strategy that I'll go through at a high level to establish an IoT predictive maintenance strategy. First, you need to make the case for an IoT predictive model. You should know what questions you want to ask of it, what criteria you want to measure, what targets you want to aim for before you start collecting and investing money into IoT. Determine what questions you want to ask of the data first, instead of saying, collect it all and let future me sort it all out. Focus on the unique problems that are affecting operations and production. It's important to understand what metrics your organization is really focusing on and what needs to be improved. Consider these questions to identify key goals for your project. What critical assets are likely to fail? When and why do we believe they will fail? How will the asset's failure impact personnel, operations, or production? What does downtime cost us? And how can data-driven decisions be really integrated within the maintenance practices that we have today? Once you've established a business case, it's all about small wins first. And the easiest and quickest win is throwing an analytics solution on top of your EAM. Why? Well, you already have an EAM that's collecting data, and the data is continually building over time. At this point, it's probably accumulated a wealth of transactional data that might not have been fully leveraged for its potential. And like I've said before, the reporting is more or less one-dimensional. You see what's been done, you see what's scheduled, but really, the reality is many still use the basic reporting, and yeah, that's good for day-to-day, and some still even resort to downloading the data to Excel and doing basic analysis. But like I've said, these reports fall way short of providing stakeholders with intelligence that draw attention to efficiency, effectiveness, bottlenecks, and risks, right? So, by throwing an analytics solution on top of all that, you can more easily mine the data, examine the trends, and establish meaningful insights for more accurate decision-making. And this is all from the data that the EAM already has. You're not collecting any more data. You're not transforming it in any way. It's just really leveraging it in a better way. See if you can answer any of the previous questions that you've come up with in the first step and attack those first. In this way, you're establishing an analytics foundation and proving out your business case. Once you've gotten some small wins on top of your EAM data, it's really time to look at all the other data sources that you can leverage. Like everyone knows, most equipment today has built-in sensors and does provide real-time information to control systems such as SCADA or PLCs, right? So with so many potential data sources, really start small by identifying 1 or 2 assets first and map out the ones that you want to work with down the line. Once you've identified and prioritized your data sources, start collecting and modeling that data. You don't need to collect all sensor data into one central location. The data may reside in disparate locations, right? In a SCADA system, a data warehouse, a data lake, a Hadoop system, wherever. What's crucial here is where you model the data. You want to model the data in one central location where it can be analyzed. This central location is where you'll continue to add to your data model as you bring in more data sources later on. An ideal analytical solution should be flexible enough so that it enables you to aggregate from all these data sources, wherever the data lies, and models it in a central location, allowing anyone to then take the model and analyze it. Once you have your data model, you can then start analyzing data to define thresholds for asset performance and create models for failure patterns. This enables the creation of rules for condition monitoring of real-time data coming directly from machine sensors. You can add historical and third-party data such as reliability models and logs to create failure patterns. The patterns can be used to further refine your rules and offer actionable insights in real time. The last step is to then operationalize all the analysis. Start monitoring the streaming asset data against the defined performance thresholds that you've created. Operators can visualize the data easily to understand potential problem areas and accelerate preventative maintenance. Dashboards can display assets and their health in intuitive ways, and you can even drill deeper to explore the health of the individual assets for further analysis. And so, how are people doing this today? I have two examples of customers within the maintenance or transportation industry that are using IoT to help them and their customers. Carlisle Fluid designs and manufactures finishing equipment for the transportation, industrial, protective coating, and specialty and auto refinishing markets. Carlisle really operates in a market that's commoditized and where the margins have eroded, making it really difficult to offer or deliver any really value-added offerings. And from when we were initially talking to them, they were telling us that most of their service reps were really, instead of selling service, running around selling volume. As equipment would break down, they would sell more. Carlisle's executives thought, if our customers were able to improve utilization and scrap, they could save a lot of money with Carlisle. And so they started a strategy where if Carlisle was able to help their customers save, they would be able to take a percentage of that savings from the customer. So with Burst, Carlisle offers KPI benchmarking and performance monitoring off of key variables in the fluid technology market. Some of the insights that they give their customers is performance monitoring of equipment, utilization of the paint guns, time it takes to paint, change the paint, idle times by shifts, and the type of hose being used, etc. Optimizing these variables creates opportunity to drive performance and increase savings for the customer, while also providing accountability to the ecosystem of the suppliers. Like, why did the failure occur? Was the machine down? Were there settings at the factory at the wrong temperature, etc.? Carlisle provides all this information to the customers, and in turn are locking in loyalty, gives them an upsell opportunity, and creates a predictable annuity for the services to perform predictive and preventative services rather than unplanned replacements. Carlisle told us that customers have shown potential savings of $120,000 to $400,000 a year, and Carlisle takes 25% of that. So that's roughly $30K to $100K per contract. Also, we heard from Carlisle that one of their closest competitors wanted to do the same thing. And in order to do that, they actually had to hire a team of 20 within their IoT department. What did Carlisle do? They just bought Burst. Our last example is PeopleNet, and they provide fleet management technology for the land transportation industry. Their products are used by more than 2,000 fleet operators in the United States and Canada. They wanted to create an IoT-connected fleet to help their fleet customers track and measure operational expenses, driver safety, and compliance metrics. The PeopleNet products included devices that track telemetry data on the vehicle. On the back end, Burst aggregates and models all this data, and on the front end, PeopleNet's customers, or the fleet managers, consume dashboards and drill down reports. They're able to monitor, measure, and send alerts on all these metrics, allowing the fleet manager to make performance improvement and cost savings. Working together with PeopleNet, the fleets have achieved measurable results, improving safety and compliance by 58%, while saving $5,000 per truck. There's 43% fewer vehicle out of service events that they've reported, and 64% fewer moving violations. And so those are just some of the things that analytics and IoT can help within the industrial maintenance industry. Thank you for your time. Mike, back to you.
All right, that was a lot of great input on this topic that, as we've seen here, is always top of mind to our audience of industrial plant operators, safety managers, just kind of anyone involved with facility operations. And yeah, we have those audience members for both our INPO audience and industrial distribution, as well as our other sister manufacturing publications. But we're not done yet with this conversation. As I mentioned in the introduction, we're now going to transition into an audience Q&A session where we're going to be using questions that the audience has been submitting in during our discussion here. And those audience members, you guys can keep sending in those questions via your chat box, and we'd love to get to them. Once again, this webinar will be made available to watch on demand starting tomorrow. So yeah, again, you'll be able to share it and rewatch it kind of anytime you want. So we've already received a handful of questions, and we'll see how many we can get through within the next, let's say, 12 to 13 minutes. So this first question, I'm going to direct it in the direction of Kevin. Real simple. I know you kind of glossed over this throughout your presentation, but this audience member simply asks, where do I start with this whole topic? Like, how do you start getting this in place?
It's a great question. It was glossed over by myself. It was glossed over by 10. And I'm sure it's going through the heads of so many that's on the phone. One of the things that was common in my presentation as well as 10's is to start with a business case. Mentioned very briefly in the last slide that I had is to start to do a risk assessment, understand what's out there, what's important. Every facility, as an example, has a lot of HVAC concerns, heating, ventilation, and air conditioning, right? You have to be able to keep things cool. You have to keep things ambient. You have to keep things at a certain type of climate control, a certain type of humidity levels and things like that. What happens if those goes down? What happens if it's a problem? What happens if you have no energy? These are things that are very important to you. These are assets that you need to have running, that you need to make run. Contact us from a services perspective, from a partner perspective, from within our partner network even. We have reliability professionals that are out there to help you conduct a risk assessment survey. And then from there, we can be able to identify where we're going to go to. This is the process of the business case justification that Tim spoke of. This is the risk assessment that I spoke of. This is where you start. You will start to look at what's the most important thing that you have. What happens if it goes down? What happens if it doesn't run right? What happens if someone gets hurt by it? These are questions that constantly go through your head and constantly go through ours. And let's get connected. Reach out to us. Help us start your journey down this path.
All right, good stuff. Let's go over to Tin with this next question. Tin, you went over some of the features and some of the the real positive aspects that Burst solution has. This audience member asks, what makes Burst different from some of the other analytics solutions out there?
Yeah, so I think, I'd start off with saying that analytics solutions are really a dime a dozen these days. And I might get in trouble for saying this, but in my honest opinion, the front end of every solution really today looks the same, right? Everyone has pretty charts, graphs, dashboarding, visual discovery, mobile capabilities, you name it, right? I think what makes Burst different is how we think about working with data and analytics and how we've translated that into our product. We have patent-pending technology, like I mentioned at the beginning. One of it is our automated data refinement. And what this does is it automates the creation of a data model. And this really eliminates the need for teams to perform the time-intensive and error-prone process of ETL and data modeling, right? And so this saves a lot of time and adds a lot of value. Additionally, we have a way of thinking about analytics or in what we call networked analytics. In a sense that we enable a networked view of the data. Burst creates these interwoven BI spaces, right? These spaces can be independently deployed or connected to other places, and it's really without the need to physically replicate the data. A lot of companies, what they will do is create these spaces, but these spaces aren't virtual. They're actually physical spaces, and the data is moved from one place to another. Burst doesn't do that. And because we're able to virtually do all this data modeling, this empowers users across different regions, different departments, even your own customers, to work with their own data model set, do their own analysis, but they're still technically connected to the overall enterprise data model. And this allows different teams, departments, customers, you name it, to really share their data model with each other, and then others can then leverage what someone else has created. So this leads to an organically growing network of insights that everyone can trust. We've also started to make a deep push in AI and machine learning, so you'll start to see that weaving into many facets of our solutions, from one-click advanced analytics, such as trending and clustering, all done in one click, to automated dashboards and insights, and natural language querying, where you could ask Burst the question, and then it'll just auto-populate answers based on dashboards and charts that have been created.
All right. Let's go back over to Kevin with this next question. Kevin, there's tons of talk out there today about just data security, especially on the consumer side where, I think it was last year Home Depot had a major data breach. And obviously in the past couple of weeks, everyone's talking about Equifax and everything that happened there. But yet there's certainly other data leaks or just security issues in the manufacturing space. So regarding industrial maintenance and these solutions out there, just how secure is the data capture process?
It's a good question. Some of those points that you brought about were data warehouse access breaches. So getting into the actual database, someone getting into backdoor access, somebody getting into secured access through the application, through different ways to be able to bore into the firewalls, to be able to get into that sensitive data elements. And those things are constantly evolving. In our deployment in SaaS, which is a software as a service, we use the Amazon Web Services environment, and we use that as a deployment mechanism. Through our Chief Security Officer, through our various groups that we have of ethical hackers, through groups that we have within hardening processes to be able to make the application secure, we protect you from a lot of those database access vulnerability points. That's one. Outside of that is another concern, I think you mentioned, in the manufacturing process and the metering process and the ways in which you sense data. It's concerning as well because it's still an IP addressable asset, right? It's an IP addressable type of monitor. It's an IP addressable aggregator. It's something that pulls information out and stores it. So it's a device that's going through and pulling this information. That device is IP addressable, so you can be able to send data, you can collect data, sometimes you can even control it. Look at these vendors. Understand what they do. Understand how they do it. Make sure you run through a very rigorous security protocol examination review. There's people like us that have audit groups that are designed for you to come in, look, test, view, understand. Find out where these vulnerabilities were. Find out what we've done to them. Find out what kind of tests that we've run. Are they modern tests? Are they tests that were out 3 or 5 years ago? What about the component processes that are on them? We have different application server environments, integration environments. There's lots of ways in which you could be vulnerable. But rest assured that a lot of that has been thought through. There are going to be some areas of opportunity for you to be able to look at even further refining it, even further hardening it, making it more secure. But I offer you the opportunity to get engaged with us. Contact your representative. Contact a partner of ours. Run through the process of review and audit. You'll find that what we have to offer is very secure, very scalable, and working in a way in which we can extend what you do into a positive light.
All right. Let's go back over to Tin. Tin, obviously, you've been, in your solution, you brought up the topic of sensors that's just kind of how it is. A lot of this data collection is done through sensors wherever they're placed. And this audience member, they asked, they know that IoT sensor devices, they generate a lot of data, obviously. So does that affect the performance of the analytics solution? Like, does it slow it down at all, or is it a pretty smooth process?
So it's a yes-no question. Yes, it can affect the performance of your analytics solution if your solution isn't built to handle all that data, right? And really this goes back to where is that data residing. Some solutions require you to actually take all that data and store it into either their cloud repository, while others have more traditional, I would say, client-server-based platforms or proprietary in-memory structures that load data into a single server, right? All this really points to a single point of contention or bottleneck for the performance. I think you won't initially see it when you start working with it, but over time, as the data grows, your performance is going to obviously drop. Now, the one way the vendor gets around that is by asking you to increase your capacity for the data. But then this is really equals more money, right? With Burst, on the other hand, we're a fully multi-tenant solution that leverages really a infinitely scalable pool of computing resources. Burst doesn't tie users or data to a single server, so there is really no single bottleneck source, right? So as you load in more data, Burst distributes this data over our network, and then there is, as our queries it through everything, there is no single point of contention. So it's really based on how the solutions architect.
All right, good stuff. And then let's go back over to Kevin with this next question. Obviously, the kind of implementation for these IoT solutions and just industrial maintenance solution, I would assume it varies based on the kind of industry, the kind of business you're in, and obviously the type of facility. But this audience member, they're wondering what implementation looks like in what you would consider a typical environment. What does a typical installation or implementation look like?
It's a good question, again, but you don't like the answer. The answer is always going to be it depends to something like that. And that's really where I recommend, again, you get engaged with us from our consulting group, from our partner group, from our reliability folks to help understand. And the reason why is because you need to look at, just as you said, the industry could vary. The different types of equipment that are out there could vary. Fleet transportation, these types of environments, they have pieces of equipment that may be able to be monitored. Some of them really can't. Could be a piece of equipment within a facility that's a structured piece of equipment, that's a supportive piece of equipment that can't be monitored as well as you would think. Then there's other ones that are out there. Data is easily accessed. LEED certified buildings, LEED certified structures, different types of existing systems that are out there that are building maintenance systems, monitoring systems, information systems. These things you can pull data from easily. So once you can get the data, doesn't mean that that's going to be the end of it. You really understand what to do with that data, how to structure that data, where to put that data, how to visualize that data. Companies like Burst, acquisition we made that Tim's on the phone with, perfect for this kind of thing, to be able to take large data sets, put them in an environment that's safe, that can be easily reported upon, and that can be used in a way to be able to implement change. Some of these different steps as you go through the process that we've outlined earlier are a little bit more expeditious than others, depending on the equipment, depending on the technique, depending on the reason, and depending on the access point and what you can do with it. So unfortunately, the answer is going to be that it depends, but the opportunity is there to engage us, to engage our folks, to engage our partners, to get a better understanding of what that risk assessment is, that business case is going to be, and how to implement it.
All right, we got just a few minutes left, so this will be our last question here. Tim, we've been obviously talking about Infor and Burst here today. Now, Infor just acquired Burst recently, so can you talk about the significance of that and what it means?
Yeah, absolutely. I think this acquisition was great for both companies. On the Infor side, Infor had its own in-house BI, which was Infor BI, but they also had OEM'd a couple of other solutions, so there was really no single BI strategy within Infor, and they didn't really put a lot of significant effort into that. And so with the Burst acquisition, they get a best-of-breed BI platform that is built in the cloud, and that really focuses on Infor strategy of digitizing and going to the cloud. And B, they have a fully dedicated team that's really solely focused on making Burst a, premium product and a leader within the analytics space. For Burst, what it gives us a ton more resources. We have access to so many more engineers, so many more partners and developers, so many more reps to really push Burst out and get it into the hands of more users. Additionally, Infor has these deep ingrained, vertical and sub-vertical knowledge in every industry and sub-industry. And so now with Burst, we're able to leverage all of Infor's kind of domain expertise in all these industries and sub-industries and really build out tailored solutions, reporting, dashboards, whatnot, packages for all these industries so that, when you do get the Burst solution, you could be fully confident that it was kind of customized for your specific needs within your industry.
All right. Well, that is all the questions we're going to be able to get in today. So that's going to conclude the discussion for today's webinar, which was titled Improving Industrial Maintenance with the Internet of Things. Kevin and Tin, I want to thank you guys again for taking the time to be here today and offer your insight with your presentations and these Q&A responses that we just went through. Like I mentioned, this topic and all these subtopics that we discussed here today, they're definitely going to remain popular talking points among our audience, especially among our INPO audience, as the Internet of Things and the overall practice of maintenance and condition monitoring data collection, as it continues to evolve and manufacturers keep moving forward with putting that data that they're gathering and putting it into action. So before we sign off, real quick, starting with Kevin and then over to Tin, do you guys have any last words or final thoughts for the audience?
First off, thank you for your time. Mike, it's phenomenal as always. Glad to be a participant. Very thankful for the opportunity to work with INPO. And for those that are listening, thank you. You could have spent this time doing something else, but you sat and listened to us. That's because these things matter. And the opportunity that's there is so real. The ability to be able to visualize, to enable, and to execute on something that's surrounding you with data opportunities is very impressive. It's mammoth. It's an opportunity you shouldn't miss. So thank you very much for your time, and we look forward to hearing you more.
All right, over to Tim.
Yeah, I just wanted to echo what Kevin said, which is, thank you for having us, and thank you very much for your time and sitting through this hour-long webinar. We know you have a lot of more important things to do, but really appreciate you guys tuning in. So thank you.
All right. Well, I definitely want to thank thank Infor for sponsoring today's event, and of course, I want to thank everyone in the audience who tuned in. Like I mentioned earlier, this webinar will be made available on demand starting tomorrow. So starting then, you'll be able to view it whenever you want and share it in whatever manner you would like. So one last thank you to everyone involved, and have a great rest of your day.